Hey Geometry, I love the title of this lesson called Incredibly Useful Ratios. Not the ratios of like chocolate chips to butter in a chocolate chip cookie, or I don't know, like milk to chocolate syrup to make chocolate milk, but this is incredibly useful ratios in geometry class. Let's get rolling. Exercises 1 through 3. Use the right triangle ABC, to answer exercises 1 through 3. This one's pretty simple. Let's just follow the instructions and fill in what we know. Name the side of the triangle opposite angle A. It is side BC. We can call it segment BC because it is a segment. Name the side of the triangle opposite angle A. We have side AC. And then opposite angle C, which is the hypotenuse, but we're going to name it angle AB. This is the short leg, the long leg, and the hypotenuse. Cool? That was pretty simple. Now let's see if we can make it harder. For each exercise, label the appropriate sides as adjacent, opposite, and hypotenuse with respect to the marked acute angle. Reminder, acute is less than 90 degrees. Okay, so on this first one, they've marked angle F as the acute angle. So this would be opposite. This would be adjacent because it's touching it. And our hypotenuse will never change. It's always across from the right angle. So if you're having a hard time finding the hypotenuse, just draw an arrow from the right angle always and label it first. Okay, so for number 5, the acute angle is angle R. Adjacent to angle R, but not the hypotenuse, is that side. Opposite angle R is that side. So where you get confusing, you think that this is adjacent to angle R, but it's already labeled the hypotenuse, and it cannot be both the hypotenuse and the adjacent, or the hypotenuse and the opposite. It has to be just the hypotenuse. Let's go ahead and do this first. Cool. And now opposite and adjacent always touches the angle in reference. Okay, here we have a little exercise. Included in this classwork set are a bunch of triangles. They're labeled Group 1 and Group 2, and they're all labeled ABC, DEF, etc. If we were in class, we would separate these triangles and let you all measure them, but we're not. So we're going to do a little exercise via video, which it's all right. We'll be good. So for each triangle in the set of triangles in your classwork, determine the missing angle measurements and side lengths. Side lengths should be measured to 1 decimal place. Make sure that each of the adjacent and hypotenuse and opposite hypotenuse ratios are set up and missing values are calculated and rounded appropriately. Okay, so what I did was I took a picture of the angle and I took a picture of the triangle and I measured an angle. So now I'm going to go back to that triangle, the piece of paper triangle, so all of ours are the same, and take a ruler and measure the side length. So I'll be right back. Okay, so I've measured both angles and then taken my ruler and measured each side in centimeters. Now if you're looking at your table right now, it's asking you to do opposite over hypotenuse and adjacent over hypotenuse. So we are looking in reference to angle A, and remember, this is my hypotenuse. So I can do 13 on the bottom of both of those. Opposite angle A is 12. And adjacent to angle A is 5. So getting my calculator out, doing 12 divided by 13, that gives me 0.92. And then 5 divided by 13, 0.38. Okay, so you're filling out your table. Next, Give me a second. I'm going to measure the sides of it. Be right back. All right, I'm back. So opposite over hypotenuse will be opposite over hypotenuse, and adjacent over hypotenuse will be 3. Oops, don't know why I wrote 5. Okay, 4/5 works out to 0.8, and 3/5 works out to 0.6. Next, okay, I've already measured one angle. Give me a second, I'll measure everything else. I think I forgot to push record and I was talking to you guys. So I've got opposite over hypotenuse, 6/8. My hypotenuse, I always draw that arrow, is 8. Adjacent, so, sorry, opposite over hypotenuse. Oh, I did it wrong. Okay, so scratch that. Let's try again, this time in blue. We're at angle 41, so opposite over hypotenuse is going to be 5.3. Adjacent over hypotenuse is going to be 6. So 5.3 over 8, 0.66, and 6 over 8 is 0.75. Sorry about that. Glad I caught it. All right, for this next one, let me push pause and label everything else. All right, if we notice, our hypotenuse is always our longest side too, always. Okay, so our ratios will always be numbers greater than, greater than 0 and less than 1. They'll always be between 0 and 1. So opposite over hypotenuse, my hypotenuse is 8. Adjacent over hypotenuse, my hypotenuse is again 8. So we're at angle L, opposite is 4. Adjacent is 6.93. 4 over 8 is 0.5. 6.93 over 8 is 0.87. Last one. Let me fill it in. Be right back. Okay, label my hypotenuse. So opposite over hypotenuse is going to be something over 8. Adjacent over hypotenuse will be something over 8. We're looking at angle M. Adjacent to M is 7.5. Opposite M is 4. So here we have 0.50, and 7.5 divided by 8, 0.94. Here's the same table. Give me a second, and I will fill in the rest for you. Hold on. There we go. I tried to write them in on the iPad, but my stylus isn't that sensitive, and it looked really, really messy. So I just took a picture and put it in your video. Now, group 2, we are going to go ahead and skip. I think we get the hang of this. I don't need to do 5 more triangles. But I'll go ahead and take a picture of the answer in case you would like to try to do them yourself, okay? There you go, the answers to group 2. Nothing different happened here, it was just all of the same type of problems again. Alright, so exercises 7 through 10. For each question, round the unknown length appropriately. Refer back to your completed chart from the exploratory challenge. Each indicated acute angle is the same approximated acute angle measure as in the chart. Set up and label the appropriate length ratios using the terms opposite, adjacent, and hypotenuse in the setup of each ratio. So let's look at number 7. So I need to set up a ratio with x and y in it. So let's look at it. And our acute angle that we are referring back to is 53. And just so we mark it, there's our hypotenuse. So if we write opposite over hypotenuse That would be opposite of angle 53, which is y over 7. And then adjacent over hypotenuse, that would be adjacent to angle 53, which is x over 7. All right, let's look back. So it says, refer back to the completed chart from the exploratory challenge. So I copied that right in here, and I'm looking at 53. So let's look at our ratios. We have 0.8 from right there. The top of this column was labeled opposite over hypotenuse. I did not copy that over. And this one was labeled adjacent over hypotenuse. So let's change the color here. This is from our chart, and this is from our chart. So now we can solve for y. I'm just going to multiply over y equals 0.8 times 7, 5.6. So we just solved for the angle, even though we don't know anything. 0.6 times 7, I have 4.2. Sorry, we solved for the side. So y equals 5.6 and x equals 4.2. So last lesson we learned about the 30, 60, 90 degree triangle, and we could find the measures of all the sides because we can set them up with ratios. Let's see, that's the ratio, this is 30, 60, etc. Well, all of these triangles aren't special triangles. They're not 30, 60, 90 or 45, 45, 90. They're random acute angles, but we can still set up ratios using opposites and hypotenuses to figure out the measurements of missing sides, which is pretty cool. Let's try another one. Okay, first I'm going to set up my ratios. Opposite over hypotenuse is, so there's my hypotenuse. Opposite of 30 is 9.2 over z. And then adjacent over hypotenuse, I have adjacent to 30, which is x over hypotenuse. I don't know any of them, but that's okay. I'm going to solve for z first, which will be very helpful. Okay, I'll be right back. So if I look at that handy chart that we did in the last example, I'm going to compare my 30-degree angle, which I cut and pasted the one from 30 degrees, compare my ratios, because they're similar triangles. So the opposite over hypotenuse, which is this one, is 4 over 8, which is 0.5. So I can get, I need to actually cross multiply this, 0.5z equals 9.2. 9.2 divided by 0.5 doubles it. Z equals 18.4. So I'm going to go ahead and replace that here, 18.4, because I have too many unknowns in that one. I'm running out of room. 18.4. So let's compare it to our adjacent over hypotenuse, which is 0.87. Just getting it from that chart. Multiply, so I have 18.4 times 0.87, and I get x equals 16.0. Okay, so I found similar triangles and I'm comparing my ratios, which makes total sense. Okay, let's try another one. Okay, number 9, I'm at a 67-degree triangle, so let me look for that angle. Be right back. So, opposite over hypotenuse. Here's my hypotenuse. Opposite of angle 67 is 21.6. Over z, and I'm going to compare it to this ratio right here, and then our adjacent over hypotenuse, adjacent to 67 is x over z, which I need to solve for first, and I'm going to compare it to this ratio, 0.38. Okay, multiply. I have 21.6 equals 0.92z. 21.6 divided by 0.92 is 23.5. It didn't tell me how to round, so I'm making my best judgment. 23.5 goes here, because that's my hypotenuse. And I multiply that times 0.38. X equals 8.9. Z equals. Awesome. We did it. Okay, this last one is a 41-degree angle, so let me go copy that over. So I need two ratios, opposite over hypotenuse, which would be, so this is my hypotenuse, here's opposite. Y over, let's just label it Z, and then adjacent over hypotenuse, which will be 120 over Z. So we don't have anything for the opposite over hypotenuse. Need to move that. So let's solve for Z here. So we're going to compare it to adjacent over hypotenuse, which is 0.75. Do some multiplication. I have 0.75Z equals 120. Z equals 160. So I can actually replace that here and compare it to 0.66. Multiply. Just multiply and I get Y equals 105.6. With that one, you can sort of see if it makes sense too. Is my largest value my hypotenuse? Because remember, that side should always be your biggest side because it's across from your biggest angle. Cool? All right. The last slide is sort of a summary. Tells you what everything is and what you're supposed to do with it. I could make a poster of it and put it in a classroom. Good job today. We'll see you next time.